Hey, Harsh here. Today we are going to talk about TCP and UDP. Before we fight them against each other, let's remember where they live. Both TCP and UDP operate on the top of IP. IP's job is just to get a packet from machine A to machine B. It doesn't care if the packet doesn't arrive or is broken or is out of order. That's where layer 4 comes in. TCP and UDP decide how the data is handled once it arrives. Think of IP as the delivery truck and TCP UDP as the shipping policies. Let's start with TCP. It is the responsible older sibling. Connection oriented, meaning we have to set up a state before we send a single byte of real data. It's like a fine dining experience at a place. You just don't walk in and scream your order. You get seated, the waiter tracks your progress and ensures the appetizer comes in before dessert. If the kitchen drops your steak, the waiter gets a new one. You don't have to worry about the details. A TCP header is minimum of 20 bytes, scaling up to 60. Why? Because it needs space for sequence numbers to order the packets and acknowledgement numbers to confirm receipt. This overhead is the tax you pay for guaranteeing delivery. Every single packet carries this administrative baggage. This is the famous three-way handshake. Before any data moves, we have a round-trip delay. Client sends sync, synchronize, server sends sync, ACK. I see you, let's sync. And client sends acknowledgement, like got it. Only then can we send an HTTP request. In high latency networks, this initial handshake is quite expensive. TCP is paranoid. It assigns a sequence number to every byte. If packet 5 arrives before packet 4, TCP holds it in the buffer until packet 4 arrives to fill the gap. It also manages flow control. If the receiver is overwhelmed, TCP tells the sender to slow down. It's not just dumping data, it's managing the conversation as well. Now let's meet UDP. This is the company cafeteria approach. There is no waiter, you just grab your tray and go. If you trip or drop your roll, too bad, keep moving. UDP sends packets called datagrams without checking if the receiver is ready. It creates no connection state, it just blasts out the data. Look at this efficiency. The UDP header is only 8 bytes. That's it. Source destination length checksum. No sequence numbers, no window size, no flags. This makes UDP incredibly lightweight and fast to process. TCP guarantees order, but that's a bug, not a feature. For real-time data, if packet 1 gets dropped, TCP forces the application to wait until packet 1 is retransmitted, even if packet 2 and 3 are already there. This is called head-of-line blocking. In a video call, you don't want to wait for a lost frame from 2 seconds ago. You want the current frame. TCP doesn't understand that. In a game like Call of Duty or Zoom call, retransmission is useless. By the time the lost packet is resent, that moment in the time has passed. UDP is perfect here. It prioritizes latency over completeness. If a packet is corrupt, UDP just drops it. It doesn't ask for a do-over, it just keeps the stream moving. You might think UDP is just for games. Wrong. The future of web, HTTP 3, runs on QUIC, which runs on UDP. Why? Because QUIC implements reliability and flow control in user space on top of UDP. It solves the head-of-line blocking and allows your connection to survive when you switch from Wi-Fi to 5G. The web is moving to UDP. To recap, if you need every bit to arrive perfectly, like a bank transaction, use TCP. If you need speed and can tolerate a glitch, like in a video chat, use UDP. But keep your eye on QUIC. It's the hybrid future that gives us the best of the both worlds. Hey, if this video helped you understand this topic, don't forget to like and subscribe. You can also drop your suggestions down in the comments about the improvements and the topics you would like me to cover next. Till then, thanks for watching and I will see you in the next one. Peace.